Hello everyone. In today's video, I'll show you how I created a checkpoint system similar to the one in Forza Horizon, where it shows you the distance in meters to the next point. I also made it automatically grow when you're far away and shrink when you get closer, so it's always visible on the screen. And since we're not using a widget here, but something completely different, I'll explain it in this video in a professional and creative way, as usual. So, let's get started. First, let's go to the vehicle blueprint. Here, we'll create a custom event whose purpose is to find the next point on the track. Of course, we need a reference to the spline representing our track. I've already made one in previous videos, so I'll use it. If you want to know how to create one, you can check that video. Back here, we use getLocationAtSplinePoint. Then we also need rotation, and of course, we set them to world. For the point index, we make it a variable. Next, we take the actor's location and subtract it from this. From the rotation, we get the forward vector. Then we use a dot node. Let me show you what we did here. As you can see, when we approach the first point on the track, the value increases towards 0. When we pass it, it exceeds 1, and if we go past it backward, meaning we are behind the point, the value becomes -1. It doesn't matter if we're on the right or left, the result remains the same whether we pass the point forward or backward. Currently, we apply this to the first point on the track, so we need to update this value as we reach each point, preparing the next point immediately. To do this, we check if the value is greater than 1, meaning we pass the point. If yes, we use doOnce. Then add 1 to the track points and add a slight delay to avoid errors before resetting. Let me show you it really works. Good. As you can see, the sphere debug always points to the next point, and when we reach that point, it immediately points to the following one. Great. But what happens when we reach the end of the track? We need to reset the track point variable. To do this, we check if number of spline points equals index point. If yes, we set index point to 0. Next, after finishing the logic, it's time to display the checkpoint points as you saw at the beginning of the video. First, we create a tall column. Then a circle. But we change the number of slices to 3 to get a triangle. We adjust its size slightly. Then I create a line above the triangle. Next, we create materials for them. Set translucent and unlit. I'll use white for the column with some light to show the effect clearly. We use world position. Mask a single channel, then subtract, take the absolute value, and with smooth step. Link it to the base color and connect it to opacity. The rest is just controlling the settings. One value determines where the transparency starts, the other determines how it appears. I'll leave them as is. Apply the effect to the column. For the triangle and top line, I'll give them a different material. Nothing complex, just color setup. This is the initial shape we'll use as a checkpoint. Next, we need to combine everything. I'll use union. Now it becomes a single mesh. Then we place it in a new actor. Add text, and increase its size. The column's rotation is wrong. It should face the plus x-axis. To fix it, we remember the rotation and apply it in the world, then use Bake Transform. Problem solved. We create a reference for the car. In Event Tick, we make a simple check, and from the text we use set text. Convert it to string, then append. In the second field, we add m for meters, representing the actual distance between the car and the next point. We make this result a variable. Then we connect the distance variable here, take its absolute value, and divide by 100. Next, we need something important. Make this actor always face the camera. For that, we use Find Look at Rotation between the camera and the actor. Then set World Rotation. Back to the logic, every time we determine the next point on the track, we use spawn actor of class. For the location, we can copy this. We make the result variable so that if it already exists in the world, we delete the previous one to place it at the next point. Let's try it. Yes, it appears, but I forgot some improvements. First, we must remove any collision. Next, we use truncate to round the result to an integer. Let's redo it. Yes, I can say it works perfectly. But if you notice, it seems far away and unclear when we're distant. This is where our next goal comes in. Make it bigger when we're far and smaller when we're close. We use set world scale, then lerp vector. Alpha comes from map range. Range A is the farthest distance for scaling. Range B is the closest distance for approximation. Then we set the final scale and original size. Time for the final test. Yes, I can say we fully succeeded in creating exactly what we wanted without issues. You can also check the channel for how to create a lap system, race ranking system, and much more. Don't forget to subscribe, and thanks for watching.